Hi, I'm Trent Buskirk. On behalf of my collaborator, Antia Kirchner, we'd like to welcome you to our talk, Big Data, Big Claims or Bigger Calamities, Getting Real About Survey Research in the Fourth Era. We're so happy to be a part of BigSurv 20, although we do miss being together with you in person. We've seen several eras of survey research develop over time. As Bob Groves in 2011 eloquently described, there are three eras of survey research to date: the era of invention, an era of expansion, and an era of design data. But we argue that the tides are rising and that changes are happening in our industry even now. Things like response rates declining, survey costs increasing, survey outlets increasing, survey paradata increasing, target population specificity increasing, survey margins decreasing, alternate data sources increasing, cell phone and internet penetration increasing. We believe that all of these things are creating a perfect environment for creating and ushering in a new era of survey research. Bob Grove said in 2011 that survey research is not dying, it is changing. The survey method has strengths and deficits that are reflections of the society that it measures and can change over time. Survey research has always and must always adapt to those changes. We are seeing the beginnings of a new era emerging. Antia and I argue in 2020 that a new landscape of survey research could easily be described as the era of survey data science. And we believe that this era, we are seeing innovation, triangulation, integration, and refinement. A lot of the work that we base our paper on occur in this edited volume that just came out that track a lot of example articles that have appeared or papers that were appearing in BigSurv 18. We'd encourage you to check it out. Our article is also inside of this volume. In the fourth era, we posit that this landscape is going to be exploring and developing new methods for data collection and data gathering. We're going to be adapting and refining current methods to use with new data sources. We're also going to be seeing comparing of public opinion and official statistics that are based on survey data sources as well as these other big data sources. So in essence, we're going to be working with and gathering new data sources, but we're also going to be innovating the traditional survey research by integrating new AI and machine learning methods to improve efficiency. We're going to be augmenting and triangulating multiple data sources, including both survey data and non-survey data to improve estimates, in part relying on other big data sources that are available. We also see this era as integrating survey data, its methods, and its capabilities into the big data ecosystem with things like data quality frameworks and data collection methods. So essentially, we're going to be seeing new analytic methods and models being developed, as well as new frameworks emerging. A lot of what we're going to see in this new era relies on or leverages the power of big data. In the rest of this talk, we're going to explore big data and look at some opportunities and challenges that exist with using these data in the survey research process. Before we get to those opportunities, though, we'd like to get on the same page with what big data means. In 2020, I synthesized the work of Jagadish and colleagues in Curry to illustrate big data as a process that moves from generation of data to management of data to the analysis of data. And big data, while likely designed and sourced at some point for survey and social science researchers, it's usually thought of as gathered or organic data. And the structure of these data sets can be different. They can be structured similar to surveys in a rectangular format, or unstructured that requires a lot more work to massage them and get them for insights. We're going to focus on 4 types of big data in this talk specifically and look at opportunities and challenges that exist. First, we're going to look at administrative and open data. And what we mean by that is administrative records in databases, population registers or sample frames, open access data on the web that may be available in the form of tax records, real estate transactions, public listings, and other sorts. We're also going to take a look at social media data. Here are just some examples in the US of popular social media outlets. These vary worldwide, but you get the flavor of what we're talking about. We're also going to consider digital trace data. This includes online transaction data, digital exhaust, if you will, internet search data, user log file data or metadata, and then web survey paradata. We believe that web survey paradata is one example of designed digital trace data that exists. We also make a note here that some authors would consider digital trace data to be a larger, more encompassing category that includes social media data. But for the purposes of this talk, we're going to keep them separate because we believe that opportunities exist that are slightly different for these kind of digital trace data than for social media data. Finally, we're going to talk about sensor data that include Bluetooth wearable sensors like accelerometers, remote sensors, and household sensors like thermostats that you might have in your home. So now that we've talked about those, I want to focus on some opportunities for administrative and open data in the survey research arena. Connolly and colleagues in 2016 cautioned that big data should be more than just synonymous with information collected through the internet, noting that commercial transactions, medical records, and various other administrative data also fall within this big data umbrella. English and others in 2015 found an increased sensitivity for recruiting households with children under 5, moving from 19% to just over 40% by combining child flags that were available from 3 vendor databases. And they found that this increased sensitivity flag was able to improve recruitment. Ten Bosch and others in 2018 described how web scraping of open data has been increasingly used in the production of official statistics, especially those around price statistics or gross domestic product. Caroli and others in 2016 used web scraping to retrieve data about agritourism and used that to create imputation to complete a national farm register in Italy that could then be used for additional surveys. Data Ugardi and Resnick in 2020 explored linking data from a national survey of education with commercially available proprietary real estate and property tax data through Zillow. And it was really cool because this paper is one of the first times that we see a mashup of these kind of data sources taken together. And with those two data sources, the research team was able to use each of the respective data sources to evaluate the quality in the other. They also were able to leverage information in the Zillow data as a possibility for that was available for both respondents and non-respondents to assess possible non-response bias. They offered a generalizable approach for investigating the quality of these data sources in an environment where we're using a linked data source structure. Some challenges exist with administrative open data that we should note here. Administrative records may not be available for every variable of interest. They may be incomplete for some variables, and they may actually be time sensitive and not updated in a timely manner relative to the field period demands. This might occur with age-specific variables like children under 5, for example. Attributional errors can also occur because open data and administrative data do not always have a user guide, so we don't always know what the variables mean or what exactly they were measuring. Open web data can also be volatile and change in its availability and format at times that are unforeseen by the researcher. APIs do seem to provide a more stable method for accessing these kind of data, but they're not ubiquitous across web sources and they're not as complete or extensive in some examples. There are opportunities for social media data as well that we want to note. Stern, Bilgin, and Ventura investigated the use of targeted Facebook ads for recruiting participants from very specific hard-to-reach populations to supplement probability-based samples. Burke and Garcia and others in 2018 explored how social media create opportunities not only for sampling or recruiting these folks, but also for understanding a particular population of interest. They argue that social media users by platform might constitute a population of interest and do posit ways to access this population to learn more about them. Finally, Schneider and Harknick in 2019 illustrated how targeted Facebook advertising can also be used to create nested samples. In this case, they used an employer-employee match data where several hundreds of employees at each of specific employers were recruited and surveyed. And in their paper, they provide a method for creating these nested samples where information about employees were not available at the employer level, even if you had a sample frame of employers. Some challenges do exist with social media data that we should be aware of. While social media data is popular, it is not ubiquitous. Pew estimates in 2018 that about 70% of US adults use some kind of social media. Not all users use alike, though. In fact, most Twitter users rarely tweet, but the most prolific 10% create about 80% of the volume. The entire population represented by a given data source may not be quantifiable at the time that you access it. For example, you may not know the total number of Twitter users that is available at the time that you institute a sample through the Twitter API. The type of access to social media may also impact the volume and content of the samples. Kim and others in 2020 noted that they had a very different return of tweets that were assembled by using the streaming API compared to the search API compared to the full fire hose from Twitter. Also, these recruitment methods through social media can be black boxes with limited information available to the researcher. There are opportunities that exist for digital trace data as well. Steyer and colleagues provided a synthesis of several ways that digital trace data are being used with survey data to improve analyses, cross-validate or improve measurement, and design survey experiments. Moeller and others recruited a panel of participants by installing a browser plugin, and they were able to find information, collect information through digital trace data this way. Wang and colleagues developed a comprehensive method for inferring demographic characteristics and used those in a weighting adjustment for deriving more accurate population-based estimates based on digital trace data. Some challenges do exist with digital trace data that we should be mindful of. Typically, digital trace data do not have accompanying information about the individual's behaviors or attributes, so it makes them difficult to be only the sole source of public opinion. Estimates. Studies employing digital trace data have also had difficulty with reproducibility, citing that some of these changes in platforms impact the availability and prevalence of digital trace data. There are opportunities for sensor data as well. English et al. Used data from 140 sensors throughout the city of Chicago to investigate relationship between air quality and health conditions. Others have also focused on using GPS access using smartphones, as well as using camera sensors to create pictures instead of answering survey questions. Some challenges with sensor data that have been noted so far is that data access is limited to consenting individuals, and when collecting, and some individuals may have different devices and may have difficulty connecting to the internet or operating those devices, and the availability of sensors and their accuracy might be a function of the kind of phone or equipment that a respondent may have. And deriving measures from raw sensor data can be challenging and requires a lot of processing on the back end that may introduce measurement error if not properly attended to. We also see opportunities for, so now that we've talked a little bit about these kind of data and some opportunities that exist, we also want to note that there are ways that the survey environment can contribute to the big data ecosystem. We have lots of experience assessing data quality, and Amaya, Beamer, and Kenyon expanded the total survey error framework to a total data error framework to be useful for big data sources. West, Wagner, and others have also looked at total data quality and looked at combining a unifying framework that incorporates gathered data and survey data or design data, and looked at the relative dimensions of quality that can be useful in contributing to the big data ecosystem and data quality assessments. We know that big data sources offer much opportunity for survey and social science researchers in the fourth era, but their use is not without concerns, as we've already mentioned. But our current statistical methods that we've used for a long time are also not always well sorted for these big data sources, so we see machine learning opportunities existing for to emerge in the fourth era as a way to leverage these alternative data sources. Antti and I have talked about this extensively and how machine learning opportunities are working through the survey research process in this article, so we encourage you to check that out. So as we proceed in the fourth era, we do expect to see a leveraging of both big data sources and data science methods for unleashing this potential. We leave you with this quote to go forth in the fourth era. Data scientists have significantly more experience with large data sets, but they tend to have little training in how to infer causal effects in the face of substantial selection. Social scientists must have an integral role in this collaboration. Merely being able to apply statistical techniques to massive data sets is insufficient. Rather, the expertise from a field that has handled observational data for years is required. So as we go forward, And after big data solves all of our problems, we'll ride away on magic flying unicorns. Until next time, we want to say thanks again for attending our talk. We hope it's useful. We've got several references here. Please feel free to reach out to us. Thank you.